Hello, this is Mr. Precella, and today we're going to be looking at some applications of algebra. This first one says, find the slope or grade of the treadmill shown to the right. Well, we've already learned that slope is rise over run. So when we're looking at this, it looks like this treadmill is rising 0.9 feet over a horizontal distance of 2 feet. So if we think of this slope and grade, this grade is just slope, rise over run. Let me see. On problem 1, we're thinking of the slope as rise over run. And that's the same thing as the grade. The only difference is usually grade is listed as a percent. Okay, so I'm not going to write a fraction here. We're going to write it as a percent. So the rise is 0.9 and the run is 2 feet. So 0.9 over 2. And let me punch that into my calculator. 0.9 divided by 2, 0.45. But wait a minute. We wanted a percent. Okay? Am I right? They're saying percent right there. Y'all see where it says the grade of the treadmill is blank percent? So how do I write 0.45 as a percent? Well, I just moved my decimal point 2 places to the right, which is the same thing as multiplying by 100. So 0.45 is 45%. So 45%. 4, 5. And I'll check that answer. Let me go ahead and move this over here. I'll move my calculator up a little. So next question. Find the slope or pitch of the roof shown to the right. Well, I think that's pretty similar to what we just did, isn't it? Rise over run. So let me see. It's 2.6 over 9.9. 2.6 feet over 9.9 feet. So rise over run. That's a 2.6. The rise is 2.6. The run is 9.9. So I have 2.6 divided by 9.9. 2.6 divided by 9.9 equals 0.26262626. How are we told to round this? Well, round to the nearest percent. So when we move this decimal point 2 places to the right, it'll be 26.262626%. So rounding to the nearest percent, are we going to leave that as 26 or make it 27? Well, the digit after the 6 is smaller than a 5, so we just leave it at 26%. Number 3 says, find the rate of change in luxury purchases in a certain country with respect to time. Let's see, so in this graph we're given here, the x-axis, the horizontal axis, that's the year, and the y-axis is the luxury purchases in billions of dollars. So it looks like the rich have gotten richer in this country from 2010 to 2017. The number of the amount of money spent on luxury purchases has risen from 8.3 billion to 27.1 billion. So a rate of change is the same thing, or just another way of saying the slope. Let me see. Let me write this down. Number 3, rate of change is just another way of saying the slope. So on this particular problem, we have 2 ordered pairs. So let's just write down those 2 ordered pairs. In 2010, it was 8.3 billion. I'll just write 8.3. And in 2017, 27.1 billion. How do we find the slope when we're given 2 ordered pairs? Well, the rise would be the difference in the y values, the run the difference in the x values. So hopefully I'll remember this formula. Second y minus first y over second x minus first x. When you subtract the y values, you're getting the rise. Let's go ahead and call this ordered pair x, first y, second x, second y. So y2 minus y1. Now the x2 minus x1, we can do that all in our head. 2017 minus 2010 is just a 7. Now what about 27.1 minus 8.3? That's 18.8. So 18.8 divided by 7 gives us 2.685. Let's see, how are we told to round this? The rate of change is about blank $billion per year. Type an integer if it's an integer. Otherwise, type a decimal rounded to 2 decimal places. Well, our 2.6857 14 blah blah blah, that's a decimal number, so we need to round it to 2 decimal places. So looking over here, the 6.8, are we going to leave it as a 6.8 or do we make it a 6.9? Well, since the digit after the 8 is a 5, we're going to round it up. So 2.69. So let's think about what that means. Over the 7-year time here, on the average, the number of the amount of money being spent on luxury purchases is rising at a rate of $2.69 billion per year. Okay, so grade, rate of change, all of that's just another way of saying slope. Number 4, oh, same type of problem. Okay, find the rate of change. So let's see. I'll do it exactly like number 3. I'm going to write down the ordered pairs. Let's see, but what is this? Down here on the x-axis, this is years. And what's on the y-axis? Average amount of tax refund check. So on this chart, it looks like the average income tax refund check has grown from $2,200 to $3,000 over what? From 2004 to 2011, that's a 7-year time. So I'm going to write down those ordered pairs. 2004, comma, 2200, and 2011, comma, 3000. So now it's just a matter of finding the slope. Oh, let me move this up. So slope, doing the same thing we did over here. Rise over run. So I'll just call this first x, first y, second x, second y. So it's second y minus first y. That's getting you the rise. Second x over first x gets you the run. So y2 minus y1, 3,000 minus 2,200 over 2011 minus 2004. That's a 2,200 there. So the 3,000 minus 2,200, that's 800. So the checks have risen by $800 over a 7-year period. So if we actually divide 800 divided by 7, it's going to be over $100 a year, isn't it? 114 point. Now, if we wanted dollars and cents, it'd be $114, and what would that be? 28 or 29 cents? 29 cents. But how were we told to round it? Oh, round to 2 decimal places. So we're going to write it as dollars and cents. Okay. So 114.285. So rounding that 8 up to a 9. So $114.29. On the average, during the 7-year period, the amount of income tax refund check has increased by $114.29 each year. Okay. There. Okay, look at this. A school club is raising funds. Oh, I better. By having a shred it day. To shred the documents, the club is charging $10 for the first 3 paper bags full of documents and $2 for each additional bag. Okay. Formulate a linear function that models the total cost of shredding X additional bags of documents. Okay. So let me see this problem 5. The club charges, I'm just trying to summarize this. They're charging $10 for the first 3 bags and $2 for each additional bag. So if you bring 1, 2, or 3 bags, it's just going to be $10. But after that, if you bring 4 bags, they'll charge you the $10 for the first 3 and then $2 for each additional one. Formulate a linear function. This is part A. That models the total cost C of X of shredding X additional bags. So the total cost is given by C of X, the cost of X additional bags. Okay, so they're charging $10 for that first 3 bags. And then for each additional bag, and we're told that X additional bags, plus, that should be a plus, it's $2 for each additional bag. Okay. If you had brought in 7 bags, then that would mean there'd be 4 additional bags. The first 3 are covered with the $10. And then if there were 7 bags, this would be 4. Since we like to write mx plus b, I'll write it as 2x plus 10. C of x equals 2x plus 10. Okay. Now part B says to graph this model using this graphing tool over here. Well, let me see. What should I do? To graph a line, and it's in the form y equals mx plus b, so it is a line. To graph this line, we're going to have to click on the graphing tool, and we need 2 points in order to graph it. Okay? Well, maybe, let's see, if I clicked it like this, no. Oh gosh, okay. I guess I'll try it like this. But if we're going to graph a line, the first thing we need to do, click the graph to plot the first point on your line. Well, the function or the equation y equals 2x plus 10. Here's how I'm going to graph it. This is the y-intercept, so that means that's what crosses the y-axis. I'm going to plot that point, and then the slope is rise over run. So thinking of 2 as 2 over 1. I'll start at 10 and then go up 2 and over 1. Okay, so let's see. I start off, you got to look real closely. Am I at 10 on the y-axis? Yes. Over 0, up 10. I'll click there. Now, up 2 over 1. Okay. If I move up 2, that means I'm going to be at a y value of 12. Over 1 means I'll have an x value of 1. Oops. I messed up. I should be looking at the point 1, 12. That's from rising up 2, right 1. It's hard to see it. It's so close together. Okay. So there's the graph there. Let me see. Can I make this a little smaller? Oh, no, it's not working. Okay, well, we've been working with these graphing tools, so hopefully I have the hang of it. There. Now, then part C. Use the model to determine the total cost of shredding 5 bags of documents. So C. How much does it cost to shred 5 bags? Okay. Well, remember, the way the model is set up, it's $10 for the first 2 bags and $2 for each additional bags. So if they're shredding 5 bags, how many additional bags is that? Well, 2. The cost of shredding 2 additional bags. The first 3 bags are covered with the $10. Then it's $2 for every additional bag. So it would be 2 times 2, I plugged the 2 in place of the x, plus 10. So $10 for the first 3 bags. How much for the other 2? $4 for the additional 2 bags. All of that to say it's going to cost $14. I should have gotten rid of that. So $14. Do y'all see how I'm getting that? You don't just plug a 5 in. The total, oh wait, let me see. The total cost of shredding 5 bags is $14. Okay. The table lists data regarding the average salaries of several professional athletes in the years 1991 and 2001. In 1991, the average salary was $266,000. 10 years later, the average salary is $1,490,000 per day. Use the data points to find a linear function that models the data. Part B, use the function to predict the average salary in 2005 and 2010. Well, let me write down these data points. I'm writing the 1991, 266,000. I'm writing these as ordered pairs. What we're doing here is finding, we're going to find the equation of a line when we're given 2 ordered pairs. That's what we're trying to do, find the equation of the line when we're given 2 ordered pairs. We've already done homework like that. You find the slope and plug into y equals mx plus b. So let's find the slope first. x1, y1, x2, y2. And let me see, how are we trying to do it? Oh, I think I've already just spotted a mistake, or I've sort of messed up on something. Notice what it says. This little trick they do to get you some smaller numbers. Let X be the number of years since 1990. Let me make a note of that. X is the number of years since 1990. See, I wrote down my two data points like ordered pairs. S is the average salary X years after 1990. So X will stay, the S will stay, it's just dollars. But you see, what I've written here, that's not right. What should these ordered pairs really be? The 266,000 stays. The 1,490,000 stays. But instead of 1991, this first X value, if it's 1991 is how many years since 1990? Well, just 1 year. Basically, you're subtracting 1990 from these X values. So at least this way you'll get some smaller numbers. So X1 would be 1. 2001 is how many years since 1990? 2001 minus 1990? That's 11. So here are ordered pairs that we'll use to find the slope. You got to read that really carefully. So y2 minus y1 over x2 minus x1. Y2 is 1,490,000. Y1 is 266,000. Now x2 minus x1 oh, pardon me, that'll be a 10. So let's see. Subtract. Oops, let me turn this on and clear this. 1,490,000 minus 266,000. That's 1,224,000 dividing by 10. That's just going to remove one of those zeros, isn't it? Divided by 10. So on the average, it looks like these salaries have been increasing by $122,400 per year. That's the slope. But we need an equation. Y equals mx plus b. So here's our m. M is 122,400. Now we need to find b. Do y'all remember doing in homework where you were given two ordered pairs, and to write the equation, you first found the slope, and now to find the y-intercept b, plug one of these ordered pairs in. Which one would be the easiest to plug in? Well, I'm thinking right here, this one. Putting a 1 in for x and 226,000 for y. So I'm plugging 226,000 No, I said 226. It's 266,000. Plugging that in for y. Now, if we plug 1 in for x, and that's going to work out pretty nicely. 122,400 times 1 is just going to give us 122,400. Now to solve for b, just subtract. So b is, let's see, 266,000 minus 122,400. B is 143,600. So is that the answer you're going to type in? No. You want an equation. Okay? So the S of x is the y. So here's our equation. Back over here. The equation y equals mx plus b. We replace the m with 122,400. We replace the b with 143,600. So 122,400x. Oh, I'm running out of room. I'll write it right here. Y equals, in place of the m, we put 122,400x plus, in place of the b, 143,600. So there's our equation. Come over here and we're just typing in the part on the right-hand side. Let me get rid of that calculator. So typing in 122,400x plus 143,600. Okay. But we're not finished. It now wants us to use our formula to predict the average salary for players in the year 2005. And what's that other year they want us to do? 2001? No, 2010. Okay. Well, remember, X is the number of years since 1990. See, X is the number of years since 1990. So we're not going to plug a 2005 in for X. What are we going to do? Well, let's subtract 1990 from 2005. So X would be 15. It's 15 years since 1990. So I'm going to plug in to my calculator 122,400 times 15 plus 143,600. So in 2005, it's 15 years after 1990. What number will we plug in over here? I'm just going to write this out, then I'll punch all of this into my calculator. Is it 20? 2010 minus 1990 Is 2010 20 years after 1990? So 122,400 times 20 plus 143,600. Pull up that calculator. Let me clear all of this off. 122,400. I'm just going to say times. If you want to put the 15 in parentheses, that's fine. Plus 143,600. So based on this formula, in 2005, the average salary would have been $1,979,600. Okay, 1,979,000. What was that? 600. Okay. And now we'll do it for 2010. Let me move my calculator over here. Oh, I'll just put it right there because we are going to clear that out. Now I'm typing in this stuff. 122,400 times 20 plus 143,600. Okay, so in the year 2010, the average salary was $2,591,600. Okay. Patch that in. There. So 2,591,600. Okay. These are some nice applications of stuff that we'd already done. Lines. Let's see. Oh, looks like this is the same type of problem. Problem 7. In 1920, the record for a certain race was 46.8 seconds. In 1940, it was 46.4 seconds. Let R of t, the y value, be the record in the race, and t is the number of years since 1990. So let me just summarize this. It's on problem 7. In 1920, the record was 46.8 seconds. See, I'm just sort of writing it out like that. In 1940, the record was 46.4 seconds. Notice it's getting faster. T is the number of years since 1920. So they're using a T instead of an X. Okay. So if T is number of years since 1920, and this is just going to get us smaller numbers. Okay. T is the number of years since 1920. So let's write these as ordered pairs. The first ordered pair isn't 1920, 46.8. The 46.8 is the y value, but what's the this first value, the x, or as they're calling it now, a t. Okay, well, how many years? If it's 1920, the number of years since 1920 would be 0. Basically, I'm just subtracting 1920 from those years. Notice how we get smaller y values, x values. The second ordered pair, how many years is it between 1920 and 1940? Well, if you subtract those, you get 20. So do y'all see how I'm getting these new t values? Now let's find the slope. y2 minus y1. y2 minus y1. 46.4 minus 46.8 divided by 20 minus 0. 20 minus 0 is just 20. 46.4 minus 46.8, that's going to be a negative number, isn't it? A negative what? 0.4? Move my calculator over here. Turn it on and clear all of that out. Did y'all agree with my 0.4? 46.4 minus 46.8? Negative 0.4 divided by 20? I wonder what they want us to do. Do they say it's okay to use decimals? Round to the nearest hundredth. So, okay, that means use decimals. So, negative 0.02, we don't have to round, do we? 2 digits after the decimal point, is that 100? Hundredths, I mean. Negative point, I might have said 0.2, it's 0.02. So there's the slope. We now need to know b. So we plug a negative 0.02 in for m. Oh, I just spotted a mistake. I'm using an x instead of a t. So I'll just continue with x, but the answer that I type in, I'll put the letter t there, okay? So just bear with me. If you're thinking, oh, shouldn't be a x. You're right, it shouldn't be, but I'm going to just work with an x. When I get my final answer, I'll put the t in. Now, let's look at these ordered pairs. Plug one of those in to find b, and you begin to see why it works out so nicely saying number of years since 1990. Because plugging a 0 in for x and a 46.8 for y, I'm plugging 46.8 in for y. Now what's about to happen when I put a 0 in for x? Anything times 0 is just going to be 0. So we just have 46.8 equals b. Hey, can't y'all picture this point? Isn't this the y-intercept? So here's our function. Y equals mx plus b. But wait a minute. Remember, we've got to write this in terms of, with a t. Oh, let me move all of this out. Should be done in terms of t. So I'm going to write negative 0.02t plus 46.8. That's what I'm going to type in. Okay, so there. Negative 0.02 t plus 46.8. Okay. Part B says, use the function to predict the record in 2003 and in 2006. So this is part B. All of this is part A. Part B, in 2003, now T is the number of years since 1920. So how do I find T? I'll say 2003 minus 1920. Is that an 83? You can punch into the calculator if you doubt it. Now plug an 83 in for T. So it's negative 0.02 times 83 plus 46.8. Coming over here. Negative 0.02, that's showing, so I'll just say times 83 plus 46.8, 45.14. Now, does this answer make sense? Well, yes, it does, because in 1920, the record was 46.8. In 1940, 46.4 seconds. So you would expect this record to be getting, the people to be getting faster and faster, and whatever the sport is, it's now down to 45.14 seconds in 2003. How are we told to round it to the nearest hundredth? That means 2 digits after the decimal point. So 45.14. I'll do the same thing for the year 2006. So in 2006, subtract 1920 to get your T. T would be 2006 minus 1920. Some of y'all are ahead of me, so 86. Plug a 86 instead of an 83 there. Negative 0.02 times 86 plus 46.8. Should we expect this to be a number larger or smaller than 45.14? Well, it better be smaller than 45.14, or else it's not a new record. 45.14 is still the record. So, negative 0.02 times 86 plus 46.8, enter. Okay, so 45.08. 2006, the record was 45.08. Okay. And now, find the year when the record will be 44.82. So we now want to know, when will the record be? When will record be 44.82 seconds. So this time, we're trying to find the year. On part B, we were given the year. Now we're trying to find the year. Well, we're going to plug in the 44.82 for the y value and then solve for t. How do I solve this for t? Well, first thing I would do, let's move. You know what I think I'm going to do? I'm going to get rid of all these minuses. I'm going to do this and that. If you don't mind the negative in front of the 0.02, then you could just isolate by moving the 46.8 over. I'm going to do it like this. That'd be a positive 0.02 equals 46.8 minus 44.82. So, hit the wrong thing. I'm trying to clear out all of this. 46.8 minus 44.82. That's a 1.98. How do I solve for t? Divide by 0.02. So divided by 0.02. And we get t equals 99. So is 99 our answer? Is that what I'm going to type in? Well, no, we want a year. Remember that t is the number of years since 1990. So what am I going to do now to this t value to get a year? I'm going to add 1922. I said since 1990. I meant since 1920. So it's 9, 11, 2019. Well, yeah, of course, 100 years since 1920 would be the year 2020. So 2019. So according to this formula, in 2019, the record should be about 44.82 seconds. Oops, right here. The predicted record is 44.82 seconds in the year 2019. Do y'all see how I got that 2019? 99 years since 1920. So I added 99 to 1920. Okay. Now, problem 8. Let me get this calculator out here. In 1990, the life expectancy for a certain country was 62.6 years. In 1994, it was 65.4. Let E represent the life expectancy in year T, and let T represent the number of years since 1990. So, number 7, T is still the number of years since, well, not still, but it's like the other one, since 1990. Okay, so summarizing this data, in 1990, the life expectancy was 62.6 years. In 1994, the life expectancy had increased to 65.4. Okay. And we write the ordered pairs here. Okay. If T is the number of years since 1990, what are these ordered pairs going to be? They're not going to be 1990, 62.6. You subtract 1990, so 0, 62.6. Hey, that's good. That's B. That's the y-intercept right there. No, this isn't going to be, this 1994, that's not going to be 1994, 65.4. What's it going to be? A 4, 65.4. So let's find the slope. Second y value minus first y value divided by second x value minus first x value. 65.4 minus 65.4 minus 62.6, 2.8 divided by 4. What's 2.8 divided by 4? 0.7 or just 0.7? So there's the slope. And to write the equation, here's the y-intercept. Isn't this, can y'all plot that point in your head? Over 0, up 62.6. Isn't that where the graph crosses the y-axis? So y equals mx plus b. Oops, I did it again. I wrote an x, and what should our variable be? T. 0.7 t plus 62.6. I wonder, just out of curiosity. Oh, wait, they've already written the t. Okay, good. 0.7 and 62.6. So whoever wrote this problem, it's very nice to y'all, because that way, if you you don't type an X accidentally and then wonder, why is it saying I'm wrong? Okay. Well, now it says, use this function to predict the life expectancies of males in the year 2008. So we're going to use this function, 2008. Well, what are we going to do? We're not going to just plug 2008 into our calculator, are we? What's the t value going to be? Well, how many years since 1990 has it been if it's in the year 2008? Well, 2008 minus 1990, is that going to be 18? So 18 years after 1990. So we'll plug an 18 in for t. So we have 0.7 times 18 plus 62.6. Should we expect this to be bigger than 62.6 or smaller? Well, bigger. So it's 0.7 times 18 plus 62.6. So in the year 2008, life expectancy 75.2. 75.2. Notice it says round to the nearest tenth, and that's the nearest tenth. Okay. And I think that's it. Okay. Well, thank you for watching this. And let's see, I have 100 on the assignment. Yep, I've done them all. So I will be letting y'all go. Thanks for watching. Bye-bye.